Welcome back. Today I'm going to teach you how to find the power of a binomial. Now, what is n choose r? We've been doing this in the calculator for the past 3 lessons, right? So what exactly am I doing when I do n choose r in the calculator? So for example, 5 choose 3. What is 6 choose 4? What is 8 choose 3? Okay, this is how it works. When I say 5 choose 3, I will multiply by a number less than it by 1, and then again, one more time, over 3 times 2 times 1. Now, what exactly is happening? I'll keep multiplying by a number less than 1 of its original number. How many times do I go? I go to the number that is on the bottom. So since the bottom is 3, I multiply by 3 of this. And then same for the bottom, 3 times 2 times 1. Okay, so 5 times 4 times 3 over 3 times 2 times 1, 60 over 6 is 10. And if you use your calculator, the answer for 5 choose 3 should be 10. Okay, now 6 choose 4. How many times must I multiply? 4 times, right? Because this is the bottom number is 4. So 6 times 5 times 4 times 3 over 4 times 3 times 2 times 1. Usually nobody writes this 1 anymore, okay? So I don't even have to write it. So 6 times 4 times 5 times 3 is 360 over 24, right? And 360 divided by 24 is 15. And if we use our calculator and try 6 choose 4, we should get 15. Lastly, I have 8 choose 3. Again, how many times should I multiply? 3 times because of this 3 here. So 8 times 7 times 6 over 3 times 2. I'm not going to write times 1 anymore, okay? So 8 times 7 times 6 is actually 336 divided by 6. And answer is 56. Again, I'm going to check 8 choose 3. The answer is 56, so it is correct. Okay, so having said that, you need to know how to perform this kind of processes with n choose 0, n choose 1, n choose 2, etc. Okay, so n choose 0, if you've been doing your binomial expansion, you know what's the answer for 5 choose 0, what's the answer for 3 choose 0. Okay, the answer for 5 choose 0 is 1. 3 choose 0 is 1. So n choose 0 should be 1. All right. Now, next one, n choose 1. You should also know by your expansion what is 5 choose 1 and 3 choose 1. What is 5 choose 1? 5 choose 1 is actually 5 and 3 choose 1 is actually 3. So what do you think is n choose 1? It should be n. Okay. Now, what about n choose 2 and n choose 3? I feel that these two are the most important that you need to know. Okay. N choose 2 is simply n minus 2 over 2 times 1. Again, nobody really writes this. So it's n minus 2 over 2. Look back here, you should realize the similarities. Okay, you need to reduce by 1 here. So same thing for n choose 3 is n minus 1, n minus 2 over 3 times 2 times 1. But I'm not going to write the times 1 anymore. Okay, so you can actually simplify this to n minus 1, n minus 2 over 6. Lastly, what is n choose n? If you remember, 5 choose 5 in your expansion, what is 5 choose 5? It is 1. What is 3 choose 3? Answer should also be 1. So n choose n is actually 1. Okay, so these are very important if you want to know how to do today's topic. So let's remove the drawings. Let's come to example 1. Given that the expansion of 1 plus ax to the power n is 1 plus 20x plus 160x squared, find the values of a and n. So many students often wonder, why do I have to learn what is n choose 3? What is n choose 2? Because they have been doing 5 choose 2. They've been doing 8 choose 3. And they can just key this into the calculator, right? So why would I need to use why would I need to learn how to do n choose 3 and n choose 2? Okay, simply because right now you can't use the calculator to do this um, binomial coefficient, okay? Because the power itself is the unknown, it's n. Usually it's a power 5 here or power 8 here, right? Then you say 8 choose 3 or something, okay? So that's why now we need to learn this. So how does it go? Again, given the expansion of 1 plus ax to the power n is 1 plus 20x plus 160x squared, find the values of a and n. Okay, so I'm simply going to do a binomial expansion for 1 plus ax to the power n. Okay, so let's just do it as per normal. N choose 0, 1, ax. So power from here goes up to this power, and this n minus 0 is n, right? They only gave me 3 terms, so I'm going to expand to the third term and choose 1, 1, ax to the power 1. Here's n minus 1 plus n choose 2, 1, ax. And here goes up to the power, and this n minus 2, and then plus dot dot dot. Okay, now I need to simplify this. So what is n choose 0? You can even use your calculator, just put 5 choose 0, put a random number, is 1. This is 1 as well, 1, 1, 1. So it's just 1, right? Plus, what is n choose 1? If you look back at previous page, n choose 1 is actually n. You can also key in your calculator what's 5 choose 1. 5 choose 1 is actually 5. So n choose 1 is n. 1 to the power anything is just 1, so I'm going to ignore it. And then this is ax. And then what's n choose 2? This is the important one. N times n minus 1 over 2 times 1. But I'm just going to write 2. 1 to the power anything is 1, so I'm not going to write it. Then times a square x square. All right? So now, plus dot dot dot. Let's not forget that. Now we can actually compare these 3 terms to now this 1 plus 20x plus 160x squared. So basically we compare the coefficients. This NA equals to 20. So NA equals to 20. I can't do much now. Let's do the second one. N minus 1 over 2 times A square equals to 160. Okay, so perhaps we have to use our simultaneous equations now. So A equals to 20 over n. This is equation 1. This is equation 2. Sub equation 1 into 2. So n minus 1 over 2 times 20 over n bracket square equals to 160. Let's simplify it. N minus 1 over 2 times 400 over n square equals to 160. So we can actually start cancelling. This is actually 200, n and n. So if we move up here, 200 n minus 1 over n equals to 160. 200 n minus 200, I'm expanding, right? Equals to, and this one goes up, 160n. So if I bring the 160n over and bring the 200 to the right, we got 40n equals to 200. N equals to 200 divided by 40 is 5. Okay, that's my first answer. If I bring it up here, sub n equals to 5 into equation 1. A equals to 20 over 5 equals to 4. And there we go. I found n equals to 5 and a equals to 4. So these questions, please take note, these questions are not common in an exam, but they are in the syllabus. So you need to know how to perform this or do this kind of questions. Okay, so having said that, example 1 is an easy example. So let's move on to example 2. Now, In the binomial expansion of 3 plus x to the power n, where n is a positive integer, the coefficients of x cubed to x4 are in the ratio 3 over 2. Find the value of n. Okay, so I think as usual, we just have to do our binomial expansion. So 3 plus x to the power n. I'm going to write smaller a little bit because there will be a lot of working, okay? And choose 0. How many terms do we need? We need until the x to the power 4 terms. So I'm not sure what is it yet. 3x. Power comes up 0, n. And choose 1, n minus 1. And choose 2, 3x. Power comes up 2, n minus 2. Okay, so these three terms are redundant. I need more. And choose 3x. Power comes up, n minus 3 plus, and choose 4, 3x power 4, n minus 4 plus dot dot dot. Why did I stop here? Because I know I have my x to the power 4 term now. Okay, so if you take a look, these are the two terms that I need. Okay, and right now they are saying the coefficients of x cubed and to x to the power 4 are in the ratio 3 over 2. So what's the coefficient of x cubed here? It is this, right? N choose 3, 3 to the power n minus 3. This is the coefficient of x cubed. What's the coefficient of x to the power 4? Over here, right? So over, and choose 4, 3 to the power n minus 4. And these coefficients are in the ratio 3 over 2. So simple. First step, I'm going to cross multiply here. 2, and choose 3, 3 to the power n minus 3 equals to 3, and choose 4, 3 to the power n minus 4. Now, to be able to solve for n, firstly, you need to know how to perform n choose 3 and n choose 4. And then you need to be very good in your indices. Okay, so what do I mean by that? Let's take a look. 2 times n minus 1, n minus 2 over 3 times 2, right? And then this 3 to the power n minus 3, I need to be able to split it up. Okay, otherwise I can't cancel. So 3 to the power n minus 4 is actually 3 to the power n divided by 3 to the power 3. Okay, now on my right side, 3 times n minus 1, n minus 2, n minus 3. 4 times, right? Over 4 times 3 times 2 times 1, which I will not write 1 anymore, times 3 to the power n over 3 to the power 4. Okay, now, right now I'm going to simplify by doing some cancellation. Okay, take note, for example, 3 times a equals to 5x times a. I can actually cancel my a. Why can I cancel my a? Because 3 times a, if my a divides over, I can cancel it, right? So effectively, if there's an A on left side and right side, I can actually cancel it. So how is this going to help me? Firstly, I can cancel 3 to the power n and 3 to the power n. Look at my n minus 1, n minus 2, n minus 1, n minus 2. 2 and 3, 2 and 3. 3 to the power 3, 3 to the power 4, cancel. I'm left with a 3. 3 and 3, cancel, gone. So I'm thinking I only have left with a 2 here. And n minus 3 over 4, right? And therefore, n minus 3 equals to 4 times 2 is 8. N equals to 8 plus 3, which is 11. All right, so now I think you are able to see why knowing how to do n choose 3, n choose 2, n choose 4 is important. Okay, so the other part of it is indices is very important. Okay, because you need to know how to split this up into this 3n to the power minus 3 into 3 to the power n divided by 3 to the power 3. This is actually your rules of indices, right? So which rule is that? Actually, it's the second rule, subtraction. 3 to the power, let's say x to the power 5 divided by x to the power 3 equals to x to the power 5 minus 3 equals to x squared. And therefore, if working backwards, if I say 3 to the power n minus 3, I should also be able to say it is 3 to the power n divided by 3 to the power 3. All right? So, what are your key points to note? Your grasp of the laws of indices is very important in this subtopic of binomial theorem. So again, 3 to the power x minus 2, you need to know that this can be split up into 3 to the power x divided by 3 square. Okay, and for questions such as those in example 2, seek to cancel equal terms on both sides of the equation in order to simplify it. Okay, I hope you learned something from my lesson. If you do like my lesson, please give me a like and subscribe to my channel for future content. Thank you very much.